All right, we're going to start section 5.3, and I'm just going to remind you that in the folder or on Canvas, I also have copied the textbook pages. You can read about all this stuff, and there are study guides to this section. But these are also my notes and a little bit about some of the problems. So an angle bisector, again, sort of resonating from what we looked at, perpendicular bisectors. If a point lies on an angle bisector, it is equidistant from the sides. So let's, again, I'll sketch in the angle bisector here. So I'll call AE. AE is the angle bisector. How would I know it's the angle bisector? That is congruent to that. It's cutting the angle in half. And if a point lies on the angle bisector, then it is equidistant from the sides. So if I take any point on here, same distance B as it is from AC. And just to clarify something, if I have some point out here P, and I want to know how far it is from this line L, how would I measure it? Would I measure it that way? Would I measure it to the shortest distance? And what is the shortest distance? That has to be perpendicular. So if I want to know how far this point M is from AB, I have to measure perpendicularly AB. To measure it perpendicularly to AC. So if AE is the angle bisector, then MB is congruent to MC. Or they're so this is there's a couple problems. Can you conclude that, or how would you conclude that? So you have to be careful. The perpendicular has to be to the side, and these have to be equal. And the converse is also true. If I know some point, and again, make sure that I'm measuring this perpendicular. I tell you that PB is equal to PC, then you can conclude that AP is a vector. So your conclusion would be that AP is an angle bisector, therefore the measure angle 1 to the measure angle 2. Or I would say angle 1 is just 3.4. So again, given congruent, conclude this is the angle bisector. And the consequence of that, we'll say if on an angle bisector side. So again, I'm going to kind of free angle bisectors. Here's angle bisector A. B. And there's the angle bisector of D. So 3 angle bisectors have a they are F. What did we say about if a point lies on the E? We didn't from the sides. So how do I measure from here to here? It's got to be perpendicular. To here, it has to be perpendicular. And how do I measure from here to here? It has to be perpendicular. And then P, Q, R. E is equal to FQ is equal to R. And they are radii. this circle right here, the in-center, because it's the circle inscribed B, C. Now, boom, boom, boom. That's a right. A squared plus B squared equals C squared. So a couple things I just want to go over. I know this video gets include that. Well, first of all, let's go back to this one. Is D on this case? First of all, I know I'm on the angle bisector perpendicularly to sides. So yes, they are D. But B equals DC. Well, I'm measuring perpendicular to A, not necessarily two sides. You can conclude I don't know that I'm even on the angle bisector. And what about this one? Yes, no, on the angle. I don't know that I'm measuring perpendicularly. Like this would be a little bit askew, not quite. So I can't include it. So the only one I can, and I conclude that I'm on the angle sector. Again, the plate needs to be perpendicular to the side. And I need to know that this is perpendicular, measuring perpendicularly, and yeah, EH must be by. Here, I don't know how that is being measured, the size. So again, and then where is this whole look at if I want to know B is, well, actually I know C and D is S is the center is equal. In this case, the 15 doesn't, and C I use the theorem B C squared. If you were doing a like the 15 squared plus would equal 17 squared. Pythagoras. And I believe that should move number